And your link hit my firewall.
This
I
meeting
couldn't
is
open it
being
up.
recorded.
All right, welcome back, everyone. Our next speaker is the awesome Dan Strickland. Dan Strickland is the software subject matter expert for the Cost Estimation Directorate of the Missile Defense Agency. In 2012, Mr. Strickland moved into his current position in MDA cost estimating, authoring the MDA Software Cost Estimation Handbook, the Interactive Software Estimation Flowchart, and co-chairing the Multi-Agency Collaborative Cost Research Working Group. Mr. Strickland is the recipient of USC CSSC's Lifetime Achievement Award for 2021, yay, as selected by Dr. Barry Bain and the colleagues in the cost estimation field. Thank you, Dan.
I appreciate it. Thanks so much, Julie. And certainly a shout out to you, Julie, and Nandi and Brad for putting this together. A lot of appreciation. Much appreciation to the Bain family for letting us, get back together. The names and people that I see, you probably won't understand how special this is to me. Late October and early November was for me to be able to get together with like-minded folks. I used to joke in the DoD realm with some of the other folks who do software cost estimation. There's only about 12 of us who walk the earth, so you're the extended family, so a little more than 12, and I appreciate each and every one of you because you kind of get me. So anyway, I promise you'll understand the title of this in a couple of slides. The Colorado Haiku Club. This is kind of the start of something that I started years ago. I wanted to do this about 3 or 4 years ago and kind of ran out of time. And then COVID hit and they sent us all home. And I've been home for over 2 years now. So I didn't really get a chance to dig into it until I was kind of spurred on by this event and by being inspired by a lot of the people who are here. So I appreciate you letting me continue my research and share it with you. It is very, very new. You're not going to see amazing results out of it yet, but there are some results and some ideas for things to do in the future. I'll let you kind of peruse the agenda. We'll be talking about SRDRs quite a bit, especially just one field called a functional description. All sorts of natural language tools associated with it, word weights and algorithms and super domains and bigrams and all sorts of things like that, but a lot of future work as well, things to go on in the future. So just take a moment to peruse that. I promise we'll get through that. So I said that I would tell you why this is titled Colorado Haiku Club, and I couldn't really put it in a chart and get it through public affairs at MDA, but I was on a special assignment in Colorado at the Springs in 2010 and 2011. And anybody in the government who's worked special assignment knows that you get pretty close with the small group that you're with, and things can get pretty hectic because you might be locked in a room and sequestered for several weeks or months on end. So kind of to pass time and to keep our sanity, we started crafting our own haikus that were attributable to whatever we were running into during our assignment. And I don't know, actually they were pretty funny, pretty hilarious. I kept them all and then printed it out for the group, and we kind of kept it as our own secret little language, if you will. But some of them got pretty dark, and some of them were pretty hysterical, but sometimes I pull them out and I still laugh at them. Haiku is a traditional Japanese poem, and you probably remember it from elementary school with 3 lines with 5, 7, and 5 syllables. That changes depending on your interpretation, but generally it's 5, 7, and 5. There are no rhyming restrictions, so you don't have to Dr. Seuss that, but I have some examples, and I put these together. And I fully expect Dave Seaver to have 5 more by the end of this. My friend Dave Seaver worked scanners into his brief on a dare from Dan, and that is a true story. There's a briefing that Dave gave at the CCRG that had a man's head exploding on it, so that was outstanding. My friend Dan Liggett, benefits of intellect, big trifecta win. So Dan, I'm going to check with you as to how you did in the Breeders' Cup after this. Kind of sad one. There is no island called Kokomo in real life, just a catchy song. Closest thing we have is Kokomo, Indiana, which doesn't really, no tropical drinks that I know of there. A very useful one, effort equals A times K-SLOC raised to the B times the EAF. So there's a haiku that tells you exactly how to do Kokomo. And then this one is actually one of the ones from the Colorado Haiku Club, if you will. Give it a rest, Dan. People don't like using SLOC. then they are all wrong. So the takeaway that I have from this is words have meaning and value. So many times we're surrounded by the words in our description of the software and what we have, but we gravitate back towards numbers naturally. I mean, what we're trying to do is come up with numbers associated with it. The challenge I took was, could words in the software records that we have in DoD have useful and quantifiable value? And I want to talk about what we use in the DoD. We use the SRDR. That's the Software Resources Data Report. It's how we collect data, and it goes up to OSD CAPE, and it's collected there within a database. Actually, there are two databases that reside within the CAPE. One that they manage themselves, and one that NAVAIR has been doing for years and years and years. SRDRs are collected again by the CAPE. It's organized and these are from the government contractors from the beginning and end of software projects. Also little steps in the middle, but we're just going to be talking about the ends of projects. They contain data like SLOC and contract type, hours, over development phases, application types of the software, all sorts of technical information about the individual pieces of software. SRDRs are supposed to be at the CSCI level. That's configuration software software configuration item. You know, if you might think of it at the SI level, that's the level at which the level of fidelity that we bring our estimates at within the government. It's the lowest level of software development at which configuration management is performed. There's lots of papers, and there's a billion out there, and I've put some out myself on CERs and data analysis of the SRDR databases. And most of them focus on these independent variables like SLOC, requirements, peak staffing. How can we get hours out of the number of requirements? How can we get hours from SLOC? How can we get hours from peak staffing, et cetera, et cetera. But there's really not a whole lot that talks about the textual descriptions that are within the SRDR. There is a field in the SRDR, and I harp on this one a lot because I like it a lot. It's the functional description. And that's a text field that addresses what that computer program is or what that CSCI does. How does it interface with other CSCIs, other elements, internal and external, the effort? It's a really simple description of a description, if you will, that says, hey, just tell me what this is supposed to do. It's top level free flowing text. It can vary in length. You can have entire paragraphs within a functional description. You can have like 3 lines within it. I generally try to tell my contractors when I review SRDRs that they need to tell me exactly what it's going to do. Some are a little better than others in their description. So what I wanted to do was take that functional description and apply natural language tools to it. Now, natural language is any sort of language that has evolved naturally through repetition and planning. Klingon would be an example of a natural language. Word clouds is another natural language tool. It's a visual representation, and you've probably seen a lot of these. It's a picture that shows how frequent words appear or their importance within a set of text data. You can express it in a frequency or in a weighted list. Another tool you can use is something called a bag of words, which kind of sounds kind of gross, but really is a representation of the text and its occurrence within a document. What you need for a bag of words is a vocabulary of known words, and we'll talk about vocabulary quite a bit, and then a measure of the presence of those known words. And as an example, if you said it was the best of times, it was the worst of times, there's actually 6 words within that vocabulary. It was the best of times worst. And then a sample vector for the line, it was the best of times, with all ones with that 0 at the end because it doesn't contain the vocabulary word worst within it. So a very simple explanation for how you might check off words that appear within text. Vocabularies need to be controlled and reduced to be effective. So a lot of times you'll see things like removing stop words or removing conjunctions in articles, the A's, the ands, the D's, the buts. You want to ignore case and punctuation. Certainly within the government, we've got tons and tons and tons of acronyms. So that may need to be ignored or corrected. You need to fix misspelled words. These are software engineers who generally respond to this, so they misspell quite a bit. And then you want to also try to reduce things down to their stem, where operations, operator become operate, and to simplify your vocabulary, if you will. So I took the SRDR functional descriptions, and I've got some ground rules and assumptions I'm using. Again, I talked about there were two. Navair produces one, and SRDR data sheet, which is used for most analysis currently. I used the May 2022 drop of that. They put one out about every 4 to 6 months. I'm only using the final SRDRs, and I have something called an alternate good quality. And there's quality attributes as to how good an SRDR record is. I only want the ones that are marked as good alteration, allocation, and combined. We can talk, offline about the importance of that, but basically, I want good final SRDRs to work with. Now, I'm starting with over 5,200 records within the May 2022 SRDR data sheet, and that ground rule right there reduces it down to 747 records. Also, since I'm working with functional description, it does me no good to have nulls or not applicables in there, so I pulled those records out as well. So the base case for this analysis is 421 records, which doesn't sound like tremendous a lot when you're talking compared to the 5,000 that I was working with to begin with, but it certainly fits the rules. I performed a word cloud using the remaining functional descriptions to try to identify what words were important that might make a good vocabulary. Use the bag of words and the reduction techniques to try to bring that down. What I want to do is have a vocabulary describing those SRDR functional descriptions. So again, there's 421 lines. Each one of them has a functional description of N words. And I'd like to pull out the important words from that could describe the software. And what what I wanted to do was use those statistics to try to predict productivity within the software records. So we'll talk a little bit about how DoD describes productivity within the SRDRs. But here's a picture of the word cloud, and you can see, of course, software is the largest value. It occurs in most of the records. Provide, system, you see these huge things, and then as it gets smaller, this occurs in less of the records. You see services is down there within some of these things. And this is just kind of a gross word cloud. There's no reduction to the vocabulary with this one. There were over 2,500 words within all those 421 records after I moved all the stop words out, A, of, the, etc. The highest number of occurring words are software, data, provides, and system. So to get my vocabulary describing an SRDR functional descriptions, I remove specific program names because it doesn't do me a whole lot of good to make a general formula about something if I've got a program name driving things. I removed all the articles, conjunctions, and stop words. Remove the specific acronyms, so CSCI, SBCI, et cetera, some of these acronyms that are specific and probably don't carry over well, pulled those out. I reduced words down to their stems, again, reducing operator and operations to operate with a T as the ending character. And then I limited it to the 96 top occurring descriptive words. So I think I got rid of provides and provided because it doesn't give a whole lot of description and doesn't add to the vocabulary that well. I'm only going to count binary participation. So does a word appear in the functional description or not? So if you've got multiple appearances by a word, the same word within one line of text, there's no extra weight associated with it. So it's either on or off. A little bit different than the bag of words, but still in the same family, if you will. Here is the list of words. That's all 96 words that I came up with. You can describe each line within those 421 lines using this vocabulary. Of course, there'll be a lot of words missing, but these are the ones that I deemed important, either by their participation or by their reduction. All right, this is kind of an eye chart, but it does give me some of the metrics associated with that vocabulary. Again, within this context, we define productivity as the ESLOC over the total software hours. Total software hours is one of the fields within the SRDRs, so I'm able to take that out. ESLOC, I use the formula we use in MDA, which is the new lines of code, half the modified, 0.3 of the autogen and 0.05 of the reuse. So again, everyone here probably knows, but values lower than 1 indicate a more difficult or inefficient coding. and productivity higher than 1 means more efficient. And kind of neat things about this, if you take a look just at aircraft at the top, the first column for each one of these words is the frequency that it appears within those 421 records. Again, software is in there 57% of the time, so 57% of the records have the word software in it. I have the min and the max, so the productivities for all the records that contain that that vocabulary word. So aircraft, the minimum productivity for the record that contains aircraft is 0.18, very low, and the max is 6.52. I also have the mean and the median to get my averages, and kind of color coded that to have the highest and lowest there. So you can see if we focus on the median productivity for aircraft as a word, it appears that it's a little bit simpler, or it's 1.88, so it's more productive on average than built-in test, and it's occurrence where it's down in the 0.55, very difficult word. So again, just a gross approximation that certain words are more difficult than others based off of the results within their records. Kind of zeroing in on what's the most productive and what's the least productive, and nobody take offense on this, but if you're an engineer, then apparently your job is very easy. At the median is 2.52, so very productive. Maybe you're very efficient. So the word engineering is a quote unquote very productive word within functional descriptions. On the other end, real time is very difficult. 0.54. We talked about built-in tests, surveillance, radar. Those all seem like very difficult words anyway. So their records carry a lower productivity on average than the others. The mean productivity of the entire data set is 1.57, and the median productivity is 1.01. I kind of like that because it's really close to 1. So there's not a lot of, it kind of indicates that this is a pretty good average, and with 1 being the Mendoza line of productivity, if you will. No outliers have been removed, but I kind of like to do that in a future endeavor. I mean, you can see that some of these max productivities for these words are astronomical, 17.2 and 15.2. Those are just Jurassic numbers, and I don't think I would accept that as being a quantifiable record. There's something going on there, but I've left everything in for this first pass. So what I'd like to do is assign a weight value to each vocabulary word to see if productivity can be predicted by the product of the active words within that functional description. So I gave a base case there with all the weights equal to 1.0, so there's no impact of the words there. So if you didn't trust this at all, this is, and you set all your productivity values to 1, how would it predict against the actual final? Again, our goal here is kind of the typical stuff with the mean magnitude of relative error less than 50% and the prediction level of 25% greater than 70 hard. Those are pretty lofty goals for an initial run, but and you'll see I'm never really even going to get close to those, but I would like to see some improvement and just kind of go with those. Again, PRED 25 means how many of the records, what percentage of the records do I get within 25% of the actual value based off this prediction. I went ahead and applied the mean weights and for each one of those descriptive words and found the products of those. Yeah, you don't want to do that. Again, since this is right-tailed data, that most of those means are above 1. And as you start to multiply their occurrence within a functional description, it just starts to jack your estimated productivity way up. So you can see that mean magnitude of relative error is just gigantic. The PRED 25 is way down. Real problems there. It's not so bad if you use the median. It's not that different than if you use the base case, though. You've got a mean magnitude relative error of 95, a little bit worse, and PRED 25 of 25, 1% gain. So there's not a lot going on there. So I'd like to make it a little bit better. So that apparently is a mission for Microsoft Solver. If you haven't played around with Solver, then please do. It's a really nice way to find values and perform some linear programming. But in this case, the weights for the vocabulary words, I started them at the median productivity values that had that PRED 25 of 25. I ran 1,000 iterations using evolutionary in Solver. And in the first case, I kind of like that one. What I wanted to do was I was trying to maximize the overall pred 25 of the model of the prediction, and I set my weight values for each individual word between 0 and 5. It seemed like pretty good endpoints. And I came up with a set. Eventually, Solver settled in on something that gave me an MMRE of 116 and pred 25 of 34%. Looks pretty good. I went the other direction and I said, let's see if we can minimize the mean magnitude of relative error and see what we can do there. And Solver again comes up with something that certainly minimizes it, but that pred 25 is so low. So I decided for the rest of at least of this presentation and this research to focus on trying to maximize that pred 25. So I'd like to miss less, but probably miss big in this case. It does find a set of weights, and it's kind of an up or down. Solver is at least as far as I can tell, not very good at multiple goals. So you want to do one goal at a time. So for the rest of this, I'm focusing on trying to maximize that pred 25 score. I decided to use that top and bottom 10 words, if you will, the most productive and least productive words, or most impactful words. Let's just focus on those 20 and solve for those 20 weights. You have to in order to do that, you've got to eliminate the rows within the data from that don't contain any of those words, because you'll get a bunch of divide by zero type stuff there. So reduce that to 421 to 220 records at that point. Just using that 220 records and just using the top and bottom mean, it's starting with the mean, the median values for each one of those weighted words, kind of reduces your pred 25. Again, you've got a lot of scores that are missing there, but I ran Solver again. Let's see what we can get out of it. If you do that and you set all the other weights of every other word to 1, so they're non-significant, and you're just playing with those 20 words to begin with, you can increase it to your pred 25 to 30%. If you go ahead and set all those other weights to their median value, it's 26%. So not really that great. I've put a little halo around the models that I like, or the runs that I liked. So this is not bad, but it's, again, you've got a limited vocabulary. There's only 20 words here, and it eliminates almost half the available data. So, you know, if I start with a vocabulary, I kind of want to stick with the vocabulary, but this kind of indicated that there is some benefit to finding out which words are most impactful or worth the most, if you will. Took it a different direction, and I started with products, and I decided, well, maybe some of weights is important. I'd like to find the distance from their average rather than the product weights, and by that I mean the directed distance. So for each word median, in this case, I was trying to find the distance from the overall median. Again, that started at 1.01. And get a list of weight distances, plus and minus. So if it's a more productive word, it'll be a positive number. If it's less productive, it'll be a negative number. So that prediction will then be the overall median plus the sum of those word weight distances. As an example, aircraft is a plus 87. It's plus 0.87 rather over 1.01, and ballistic is minus 0.30. So if you had a functional description that contained only the words aircraft and ballistic from the vocabulary, your predicted productivity would be 1.01 plus the 0.87 and minus the 0.3 to get 1.58. Went ahead and duplicated that same effort using the mean. You can use the mean in this case because we're not doing products, so it's not this massive multiplication of positive numbers. So in this case, the sum of the median weights was the pred 25 is 22, not really that great, and then the using the means 18%, not really great at all. But carrying it a little bit further, I can use Solver, and instead of just using the distances I have, I can kind of cheat it a little bit and say, hey, instead find something between -1 and 2 for each one of these words. Again, running 1,000 iterations, and as the starting point, we'll use these medians from the previous page, and got kind of a pretty decent result there for number 4. Solver found pred 25 of 37% over that 22%. So pretty nice. I'm kind of, I was happy with that one. I mean, if you can be happy with the 37% on Pred 25, but again, this is just the initial start of some data, so there's probably a little bit more missing there. I decided to put my degrees to work and do a brute force algorithm. Sometimes I don't trust solver. I like to kind of code myself and tinker a little bit. It's very simple. In this case, it's just a nested loop within Visual Basic where the user can define the number of trials. Again, we were using 1,000 before, a little bit slower inside of an actual Visual Basic interpreted run. So you can set the default or delta value for the incremental change in the word weights. In this case, I set it to 0.01. And what this will do is randomly traverse the vocabulary. So all 96 words in this case, it'll go through each one of those in a random pattern, changing the value of that word by the delta. So if the Pred 25 score improves, it'll keep the new word weight. If it goes down, it moves back to the previous word weight. Very simplistic there. If it doesn't change at all for 3 straight increments, it keeps the new word weight and just moves on to the next word. It does this for both increases and then decreases the value. So it's in description, it is exactly what it is a brute force algorithm. Certainly not optimized. I don't know. It probably runs in like a big O of n squared time or something insane like that. It does tend to get stuck after the first set of improvements. So, I have outputs so I can sit there and visualize and see how it's moving. And after a while, it just kind of sits there and doesn't do a whole lot of anything. So it tends to elevator quite a bit, go up, then go down to the exact same place. There are things that need to be improved about it, but for the first pass, I decided to use that as well. So I started with the base case where everything is equal to 1, and just said with no other knowledge about what these should be set to, what would the brute force algorithm come up with? And it didn't do poorly. It came up with a Pred 25 of 31%. The most interesting thing about this was the range of weights was 0.76 to 1.02. Again, this is the product model, same sort of thing we did originally. But there are 42 of those 96 words at the end that end up at 1.0. So about half of the words using the brute force algorithm are just not significant to the model. So I thought that was kind of interesting. When I started at the median, and this could be with some cheats associated with it with smaller medians, the brute force model started to give me some negative weights, and that doesn't make any logical sense. It came up with the same Pred 25, but it does, and an even better MMRE. But it's got some things in there that just don't make any sense with negative weights, and not something I want to put out. So kind of like that 6th run there. So actually showing the results here, and take them as you wish. Again, this was the best result of the products using Solver. And the model there says productivity equals the product of all the present word weights in a functional description. You see your Pred 25s, and I took it up a little bit further and said, hey, if I reduce the accuracy that I needed with this Pred, if I took it to Pred 30, Pred 40, Pred 50, how does it move? Does it get a little better? Of course it will, but it's at Pred 50, so the weight comes within the prediction of the productivity comes within 50% of the actual productivity 53% of the time. Still doesn't match what I want for a model, and I'm not sure anybody would put that out there, but it could be used in early estimates and cross checks. If you knew nothing else about the software that was being developed other than a description from someone, something equal to a functional description, just the words associated with it. If you said, what is it going to do, and wrote it down and checked these off, you would have a starting point as to what your productivity was if using this method. I did the same thing. Here's the model for the sums. Again, you'll see the negative numbers in there. The negatives are harder or more difficult words. You got your productivity equals that 1.01 plus the sum of all the present word weights. The Pred 25, this is the best of all the models, the best starting point, but that prediction level starts to draw even with whenever you start to increase that value up to like the Pred 50s and such, they start to converge on each other. And here's the results from the brute force. Everything that was at 1.0 is grayed out because it's not significant to the model. Again, the product of the words. It's kind of it does it's very limiting. I mean, it reduces the vocabulary to 54 words, but it does limit the data that can participate. Again, from when we did the most significant 20 words, we started to leave a lot of records out because they just couldn't participate. So the same sort of thing here. I'm not a big fan of things that can't participate, but I do kind of like the idea of being able to program. The best thing about brute force and programming your own is again, you can kind of program in multiple goals, if you will. Hey, let's get to the highest score for this, and let's get the lowest score for the MMRE at the same time. But it is a little ponderous, or a little, you know, in terms of its production at times. So it needs some cleaning up. Within the SRDRs, we have application domains, which are kind of a rough description of the family of what the individual records or program is supposed to do, and then those are grouped into super domains. We talked that was talked a little bit by Dave Seaver today, but there are 4 super domains within the SRDRs: the AIS, automated information systems, engineering, mission support, and real time. Within anything within this data set, the 421 records, and within the total data set, real time dominates the participation. So within this data set, it's like 73%. It's almost, you know, 3/4 of your data. A lot of times we might use mean or median productivity of a super domain as a baseline for our early estimates. So if we don't know a whole lot more, we can say, hey, we know that this is a real-time effort. On average, real-time efforts are 0.83 ESLOC per hour, kind of thing. So what I wanted to do was to see if super domain affected these vocabulary words at all. They're kind of similar to each other, but not the same. Again, a super domain is check one of these boxes, and then it is kind of sent to the individual 4 super domains as to a description. The functional description is free flowing text. So the performance AIS, if you just took the mean of AIS records, it's PRED 25, 16%. So if you just took the mean of all information systems and said, all right, this is the mean productivity, how's it perform against the final for these records? Only 16%. Medians at 32, and then the word weights, which again would in this case ignore AIS, other than it's a subdivision that it doesn't know anything about. It gets to 32% as well. Engineering, it outperforms the median and the mean. Real time, it outperforms it, and mission support, it outperforms it. You can't take a whole lot away from that mission support, since there's only 3% of the records associated with it, but it does, and that's so, you know, the best result product, the very first of the 3 that I showed you, matches or outperforms the mean and median productivities by super domain in prediction level at in PRED 25. But as that prediction level is expanded, which I was playing with and bringing it up to 30, 40, et cetera, the mean and median values can catch up to that base, to that best case product. So within those individual super domains. So you know, I wouldn't run off to the hills and ignore the facts that we use. Hey, this is the average productivity for super domains, and say, no, we need to turn this around with these word weights that Dan gave me. You know, you could probably get away with doing the word weights. It's certainly a good cross check, but it does tend to outperform it when you don't know the super domain. So everything, you know, unknown, they're in that all records, if you will. It does very well. So knowing the super domain certainly helps a little bit in defining what the productivity is early. You won't do poorly if you just have a description that's equal to the functional description. Within the bag of words, there's something called a bigram model. That's kind of the next family of the bag of words. It uses coupled sequenced words and calculates those statistics using the couplings. Again, using that it was the best of times line. The bigrams would then be it was the best, etc. Sequences is important here because aircraft and then a bunch of words and software is not the same as aircraft software together. So aircraft and software would have to occur together for a true bigram model. I don't have any processing tools for collecting bigram models, and they don't seem like they're readily available, but didn't have time to really dig into finding some. But if they were out there, they could lead to a stronger vocabulary. There's a lot of thought in the bag of words tools that that your accuracy becomes so much better with bigrams than with these unitary words. That vocabulary would still need to be controlled and reduced to increase the effectiveness. The same rules we did before, but I see a potential to use pairs of present vocabulary words to look for quote unquote bigrams. In this case, it's more like tuples, aircraft and software together occurring within a line, as opposed to aircraft and bit testing or something occurring together. But you can understand if you've got 96 words and you want to measure potential pairs, that's over 9,000 potential pairs. So that's a lot of processing that needs to go on. Didn't have time to do anything like that, but it would be interesting to see those 96 unitary words then brought in together to be these tuples of words, if you will, and even more interesting if bigrams are possible. I'm just not sure that there's a whole lot of bigrams that occur using the vocabulary that I've got defined right now. So it would be quite an exercise maybe to start again with it. But again, even with 421 records, you can imagine the amount of text that would have to be processed. So in the future, what I'd like to do is expand that to that bag of bigrams or even bag of pairs model with the aircraft and software together. So these unioned vocabulary words. I need to mess with that brute force algorithm a little bit. I'd like to give a little more range and less of that settling effect. I talked a little bit about multiple goals. That's kind of the cool thing is maybe I can look for several things at the same time to improve. I'm interested in that sum of weights model using directed distance. That one seems pretty easy to describe and had some really good. It was the best initial effort in terms of the Pred 25. So the best accurate of a bunch of not very accurate models at this point. But I played around with this a few years ago in terms of solving for the word weights in the products using a set aside random training set and then applied to another random test set. So a lot of people do that in terms of here's a smaller test set that I'm going to set aside, and then I'll train everything associated to the vocabulary from this larger training set. And then there's a lot of ability to apply these natural language tools to other text fields within the SRDR. Within the Agile metrics and Agile features that we have within the new SRDRs, we have feature descriptions, which is kind of in the same family as functional description. Actually, the contractors do a lot better job on that because it changes release to release or even SRDR to SRDR, a full description of what each feature does, planned and actual. So it would be kind of nice to apply those natural language tools to that and then potentially have a vocabulary for features associated with that. I know Dave talked a lot earlier today about costing by feature. It would be kind of nice to be able to say, well, describe the feature to me, and then maybe we can get a start for the productivity associated with features that you're describing. Development contractor is a text field in there as well. It might be interesting to pair the functional description and the individual contractor name or site. And that may scare some contractors if they're on, but trust me, we do this sort of thing. So that would be kind of interesting to get a tuple between when Boeing describes aircraft software, is it different than when Lockheed describes aircraft software? A couple things to take away with you. I mean, this was kind of cool. Like I said, I've been trying to do it for years and kind of set it aside and sat there collecting dust, and then got fired up after talking to Dan Liggett and Dave Seaver a little bit. And so it's nice to break out the SRDRs, the functional descriptions, and come up with this vocabulary. I like 96 is a pretty good number. You can assign the weights. You can use tools like Solver and Visual Basic to come up with things to help you with those weights. Those weight solutions, I liked how they performed against just the super domain medians. So that's pretty nice. So it gives me a little hope that this is something to use. And for one thing, it's just different. I mean, instead of taking the tired beat up, here's SLOC, here's eSLOC, here's requirements, here's peak staffing and how do I get the hours from it. This is something that's a little bit different in using the text, and I like the idea of using these natural language tools to get some focus on those texts. So, the key takeaway being that these words do have meaning and they do add weight, and we are able to use that and use it for prediction. So I think it's exciting. I think there's a lot of future in it. I'll be doing it over in our research group, and certainly encouraging others to do it as time allows. So with that, I'm done. I'm open for any questions.
You should look at the chat. Lots of stuff in the chat.
Crap. Okay. Let me see if I can get through any of it. Okay.
Dan, I gave you the code for that. The bigrams.
Okay. Bigrams code. Poem generator org UK will generate haiku in a second. Yeah, all right. Those who want to pay for membership. All right. String as advocate. Thanks, Ray. I'm gonna have to put my computer science hat on again. But cool. I will actually copy that. Excellent.
And anyone else who has got comments or questions, you do have
And
a
I'm
couple.
and then Dave wants me to share it with Lyle at NGA. So.
Oh, this is Jairus. So
Hi, Jairus.
hi, we did this. We played around with text mining twice that I can remember at this stage. We found that well, at least in terms of parsing through words and counting them, that people use words different ways. Now, maybe
Sure.
for risk. So we were down in the bowels of words and we found that the tools generally might get you about 50% of the things properly identified. But the other 50%, we pretty much had to go in by hand to go through them and do our best to figure out what was really meant by the word. And then we either threw it out if we couldn't, or put that new word in, or put a way of recognizing combinations of words and knowing, oh, these are all the same thing. And that greatly improved how we could predict and how it performed.
Sure, and I can see that really. I mean, one of the problems with SRDRs, and I see so many every day, and I don't really have time to read through each functional description, although I'm the one who was a stickler to keep it in the information. But one of the things I find is contractors tend to regurgitate the exact same thing every time. So it's even if it's bill number 10, and it's different what they're doing with it. The intent was, tell me what you're doing that's new. It will be the regurgitation from build 1 or build 2, and exactly what you're saying is, well, maybe this is kind of what somebody dreamed up with a description, or they pulled it out of a document. I'm hoping that if I move on to the agile metrics as those start to fill in, the individual features will be a little bit better described, if you will. But they're on average they're smaller and they're shorter than the others, so just haven't had time to mess with it just yet. Appreciate it.
All right, anyone else? All right, thank you.
Anandi, I owe you a phone call or a meeting, don't I? Yeah, I hope this was kind of in the wheelhouse, and you can see kind of what I was thinking and doing with it. But
I had to miss part of your presentation because I'm in another meeting, but definitely
unacceptable.
I want to talk more about this.
No problem.
Don't forget, everyone, a copy of these presentations and the recordings will be made available upon request. Just email me and let me know which you want. If you are like Windsor and you want it all, I will have a zip drive prepared but you have to ask. You have to ask me. So, all right, thank you so much. Next presenter coming up is Sam Fleischer. Sam, if you're on, go ahead and share, please.
All right. Hi, everybody.
Hi.
Thank you.
While Sam is setting up, Sam Fleischer is a systems engineer in the systems modeling and analysis group. His work includes planetary protection systems modeling for early mission concepts to icy moons, risk analysis and mission operations, including M2020, and uncertainty qualification and communication using Bayesian and machine learning methods in early formulation resource models. Sam is the project manager for the analogy software cost tool.
Folks, I need to log out of Zoom and log back in really quick in order to share my screen.